going on, everyone? Today we're doing daily temperatures. Okay, and sorry, I did code this up while my microphone was on mute, so I won't be posting that, or maybe I'll post like a fast coding session of it. But I did explain that I went to the iPad, I whiteboarded for about an hour trying to figure out the more optimal solution. Wasn't able to do that, so within that hour, the last like 5-10 minutes, I coded up the brute force solution just to get some code out there to kind of build some momentum, I guess, to feel somewhat accomplished, not totally broken. So I was able to code up the brute force solution here, which runs in O(n) squared time, and that uses 2 for loops. Okay, and then this was accepted, but it's not very fast, as you can see. So I'm not satisfied with this solution. I want to make it faster. I know there's probably an O(n) or close equivalent solution out there, and I was able to do some research and look at the solution. So now I'm going to code up the solution that I've just whiteboarded on the iPad. So here we go. Okay, run the code. Looks great. All right, and let's try to submit it. Great. So this is a lot faster. So we use it's 50% faster. So it's 50% faster, 52% faster than Java Online Submissions, and it's a little bit slow, or it uses a lot of space with the memory usage. Before we didn't use as much space because we didn't have this extra like object, and we didn't use a queue. But this is significantly faster. Okay, so let's do a quick recap of what we need for daily temperatures. What is the optimal solution? So I was able to do this today, so let me show you what I've done here. And maybe right before I get into the code, let me explain the concept of the optimal solution that we're going to use. So it's using a stack. So we're going to switch over here to the iPad, and let me try to write this up here. So okay, so going over to the iPad here is the solution without code. So just kind of whiteboarding it out for you to understand the concept. So here is the input array. So we have the input array here, and these are daily temperatures, and we need to return an array. So the output, oops, let me use that. So the output needs to be another array, the same size as the input array, but we're going to return the temperature, or the next day, or how many days from the current day is it going to be warmer than the current day. So 73 today, so when's the next day it's going to be warmer? That would be the next day. So we're just going to say 1 for this one, and let me just put a line here so I get them all correct. And let's just put the indexes up here, 1 2 3 4 5 6 7. Okay, 74, the next day it's supposed to be warm is the next day, so on and so forth. So I'm not going to fill this out right now because I'm going to let the 6 7, I'm going to let the algorithm do that. Okay, so how do we solve this? We can solve this using a stack. Okay, if you remember the stack data structure, it is the LIFO method, so last in, first out. So if we put something in and then we call pop, so we push something in and then we call pop, then the item that we just pushed in, regardless of how many items are already in the stack, the one we just pushed in is the one that comes out. So it's like a stack of plates. When you stack plates on each other, you're just going to take the top plate on, but that is the last one on there. Okay, so I think you guys get the idea. Okay, and so we're going to use a stack here, but we're going to use a special stack node that holds 2 pieces of information. We want to hold the value, and then we also want to hold the index of what we're putting into the stack. Okay, so the algorithm is going to go like so. So we're going to be iterating through this array, and we have a current index, and let's say that is 73, and then the index is 0. Okay, so there's nothing in the stack, so we're just going to push that onto the stack because we haven't seen any more days in the future yet. So let me just split this in half here. So this is going to be the index, and this is going to be the value. So we'll say it's 73 and 0. Great. So then we get rid of the cur, and now I was there, but now I is going to move to here. So cross this guy out. So I is now at 74. We look at 74 and index 1. So here's the part where we need the tricky or clever algorithm to look at the stack. So we look at 74 and then we peek the stack. So we look at the first element on the stack and we say, is 74 warmer than 73? So is it higher than 73? So 74 is greater than 73, right? So that means we can now answer 73's problem. It doesn't know. Its problem is that it doesn't know when the next warmest day is, but 74 came along and now we know. So how do we know how many days it's been? We take this index and subtract it by this index that was in the stack. So we pop this guy out of the stack. So now we have 73. And then we also have that index of 0. So then we say 1 minus 0, so that's there. That's how many days it's been. So then we put a 1 right there. And then we keep doing that through the whole algorithm. So let me go back here or erase. Okay, and then once we pull out 73, then 74 gets put on the stack. 74 and 1. Okay, and 1. Okay, and then what's next? So next would be I of 75. So then we have 75 and 2. Is 75 greater than 74? Yes, it is. We do the same calculation. 2 minus 1 is 1. Sorry, and then I need to fill this output array out. So that was 1, and then now we're going to put a 1 there, right? From the answer of 74. So then we pop out 74 from the queue or the stack, erase all this stuff, and I goes to the next one, and we push 75 and 2 onto the stack. And we got I right there. So hopefully you're following this and seeing the pattern. If not, you can watch it over and over again and look up resources online for sure. That's how I figured it out. Let's see, we got 75 and, sorry, not 75. We have 71 and 3. Okay, so that's now our cur issue here, right, is that 71 is cooler than 75. So what does that mean? We just need to put it onto the stack because we can't solve 75's problem. 75 does not know, like we still do not know what we need to output right there. So then we're just going to put on 71 and 3 onto the stack, increment I over, and let 75 and 71 wait for another day to determine when it's going to be hotter than its current day. Okay, and then we are now at 69, right? So we got 69 and 4. Okay, 69 and 4. This one also is cooler. So this one's another candidate where we just put it back onto the stack and increment I over here. Okay, so now I is 72. Okay, I is 72 and what? It's 5. Okay, 72 and 5. So now we check what's on top of the stack, right, with every cur element. So 75 is greater than 69, so we say 5 minus 4. We pop this guy off at the stack, and that one will now get an answer, right? So 69 will get an answer right here of 1. 72 is also warmer than 71, so we'll pop this one off the stack and do 5 minus 3, so that's 2, so 71 gets an answer. However, we try 75, but it's not warm enough, so we just push 72 and 5 onto the stack. And yeah, let me get rid of all this stuff. Okay, so now we have just 72 and 5, and then 72 and 5, and then 75 and 2 on the stack. Okay, so where are we at now? So this one's still a question mark, so then we move I over here. So I cur is now 76 and 6 is the index, and looks like 76 is able to accommodate or figure out 72's answer. So we do 6 minus 5, right? We'll pop this guy out. And this is a 1 here. Great. And then 76 also can solve 75's issue, right? So we pop 75 out. And we do 6 minus 2 to get how many days it's been. It's been 4, so then we add 4 to 75's problem. Okay, nothing left on the stack, so then we push it back onto the stack. Push 76 onto the stack. Okay, and then we move I to the last element here. And same thing, we check and see if 73 is greater. It doesn't look like it is. So what does that mean? These will kind of just stay on the stack actually based on my algorithm, but we could like dump out the stack and make sure we're zeros. But what is cool is that we initialize this output array with zeros already in our algorithm, so these can just stay on the stack and get garbage collected or whatever when our function finishes. Okay, so hopefully that made sense. Give a little smiley face to give you encouragement to keep going. But yeah, that is the iPad part right there, so hopefully that makes sense. So let me jump over to the code. All right, so this is now everything I talked about, but in Java implementation. So like I said at the beginning here, we have an answers array. That's our output array. And by declaring the size here, by default, Java will put zeros in all of the indexes for us already. So that's a nice point. All right, and then we have, excuse me, we have a queue that we've defined here. I should have called it stack. I don't know why I called it queue. I guess I've been doing some queue problems maybe. So it should be a stack. And then we iterate n times, over this temperatures array here. So we pop out cur. We check and see if the queue is empty. And if it is empty, we just push it. And then it kind of goes back through. Else, if the queue is not empty, then we start that while loop, right? So we're over here. And we're going through this stack in a while type fashion. So that's what this while loop here is. So we check to make sure it's not null, or sorry, it's not empty. And then if the temp value is less than cur, meaning we found a higher temperature, then we set the answers array to the temp.index. So remember what a temp is. So where's temp come from? Let's see, where does temp come from? How come I'm not able to see where temp is declared? Did I? Okay. Yep, I did delete something. Sorry about that. Okay, so temp, node temp is what we're peaking. So we peak at the first element. So that's just pulling, it's just reading the first element off the stack. And then one other thing to note here, this is kind of a convenience that I did, but I created this custom node class that holds a value and an index. So that is this stack node here. So I have value and index there. Then I created a constructor and then a toString method so that I could print out some things, as I was going through, so that you can have nice output when debugging. And then, I set the index to I minus temp index. So that's down here, this little subtraction problem. That's right here. And then q.pop, we pop it out once we know its answer. Okay, and then if we didn't find a higher temperature, we break from the queue because we know that none of them under that are going to help solve our problem. So then we just push that new element, let's say it's 76 here, onto the stack. And we keep going through and then eventually return answer. So I was able to submit this and I was able to get 52% faster than other online submissions, which I think is pretty good. And this also runs in on time because we're only running each node of these once, right? So there is a while loop inside here, but we are popping off each of the items on there. So it does not go to like n squared time. It's on time for this problem. And it uses on space because the queue could get filled up to n times. And I guess we use this answers array as well. That could use n space. Okay, so hopefully that made sense. Thanks everyone for watching. We'll talk to you later.